Weedhopper of Utah. I've been working with the Chotia 460 for quite some time now, two years or so. And I'd like to take some time with you today and share with you some of the knowledge and experiences that I've gained with working with this engine. Now, if you're going to do some repairs or some assembly with the 460C, you're going to need some tools. And I'd like to show you some of the tools that we use in the assembly shop. First of all, use an open and closed end 7/16. Here's a socket 7/16 with a ratchet. Here's a 5/8 open and closed. Here's a 1/2 inch. Here's a 5/16. This is a 12-ounce ball peen hammer. Small rubber mallet. This is a 5/8 bear claw. Torque wrench. And a 5/8 socket with an extension on there. You're going to need some sort of a ring compressor. To do your timing, you're going to need some sort of dial indicator. We like this one because it has the threads on it that will screw right into the spark plug holes. Your feeler gauges. And an ohm meter. Okay. A couple other things we use in the assembly is a can of acetone, a can of the type of oil that engine runs on, and a tube of silicone. This is just the clear silicone rubber adhesive. You can usually get it at any hardware store. And with those, you ought to be able to do a fairly good job at assembling any of the Chotia 460 engines, whether it be the A through the C. Now, the first thing that you do, the first project you're going to undertake is the crankcase. Here's what it is. Okay. When you're working on it, say that you've torn this engine apart and you look at it, the very first thing that you want to do is you'll take a look at the color of oil, the color that the metal has taken up. Now this is a brand new engine, so it hasn't taken on a coloration yet. But sometimes if an engine has been run too hot, you'll pick it right up because there will be a tarnished kind of a brown right into the metal, and you'll be able to see it right in there. You'll also be able to tell if the person has broken into their engine and maybe sealed the engine back up with the wrong kind of adhesive, because there will be bits and pieces of it here in this area and also in the rear case bearing area. Now, if you see any of those kinds of things, what you'll have to do is get the bearings from us and actuate a repair. Now, to put it together, the first thing you'll do is take your oil, and you need to oil up the bearings. And then feel them. Feel if they have any roughness. Just make sure that they're running real smooth inside of the crankcase. On the front and the back of the front case. And the very same thing on the rear. Turn it around, and I can feel that. I can feel how much friction there is between the balls and the outer race of that ball bearing. Okay, now that you have everything all oiled up and slick, it's time to put on the crankshaft. But before you do, you'll note that there's these two brass shims. Now these shims are different widths in dimension. This one is 25 thousandths, this one is 15. Now this dimension varies on the different engines, but on the C model, that's the way it is. The 25,000 shim goes on the front, just like so. And the 15 goes on the back, just like so. Okay. When you have those on, then take your oil again. Just put a thin film of oil on there and rub it around the shaft. Put another thin film on the back shaft. Take a little drop and put it inside the bearing. Run the bearings around. Now we'll get to the top bearing in just a minute. So when you got it all this far, take the shaft, hold the rod in this position, and let the crankshaft fall right in. Okay. Bring up the crankcase and put it into this position with the rod at bottom dead center. Now, we can put this aside for a second because we're going to work a little bit on the rear case. I'll take my silicone seal. I'm going to take just a little bit and just daub it on there. When you have that finished, take the front and the rear cases and put them together. Now, as long as you've got them together like that, take a couple of bolts and nuts. And put them through the tabs. This will help when the silicone is drying up a little bit to seal the engine. Now, when you get that completed, you're ready to put on the prop flange. The prop flange consists of 3 or 4 little parts. Just the flange, bolt, has a little star washer on there. Then there's a woodruff key that we're going to put into the crankshaft. See if I can get this to where you can see it all. To do this, I use my 12-ounce ball peen hammer. I just take the woodruff key and I put it right in there and I give it a little tap. Then take your prop flange, just slide it on, tap it on with your hand, take the bolt, put the bolt on, should spin right in. Now there's a torque dimension on this bolt at 60 pounds. Let me show you how we here at Weedhopper do that. We've made a special tool. It's just a bar. It's got a place cut out here for the bolt, a couple bolts in with a couple of prop bolts. Now, I'll show you how it works. Take that bolt and start it in. This, by the way, is where you'll use that 1/2-inch wrench. Or it's where we use it anyway. Just just to kind of snug this down. Now, I don't think you can see this very well, but I want to get enough threads in here that it's coming all the way through the flange. So don't quit halfway. Okay, we got her there. And this one spins in real easy. And I got her there. Now, take that little tool. I'm going to use my torque wrench. This is an especially nice torque wrench. It's got a little locking device down here. I can dial in how many foot-pounds I want, and then I just lock it up, and it won't slip. Okay, then put the socket on there, and just tighten it down. This particular procedure is part of the Weedhopper Charlie Atlas course. Okay, you'll hear that little click. That means that the torque wrench has well, you're pulling 60 pounds on it is what it means, and so you're done. So take the torque wrench and we'll put her back. Take off this little tool here. Okay, there's what your engine looks like so far. We've got the crankcase put together, the crankshaft put in, and we've got the prop flange on. By the way, you'll note with this particular engine, we've done some pre-assembly with it, and we've put in the impulse nipple already. This is a quarter or an 1/8" pipe tap nipple, and you just put it in, put a little tiny bit of silicone around the OD of that, the outside dimensions on those threads there, just a little tiny bit, and then screw it in. Now the reason for not putting a whole lot is you don't want to get that silicone to come down underneath the threads and to coming up inside of there and hardening up. That will, because then the impulse will be restricted, and the fuel pump on the carburetor won't work as well. Now, when you're finished with that, it's time to put on the piston. The 460C has a different bearing arrangement than any of the others. We've started to put in these extra heavy-duty needle bearings, and they don't have an outside race. The top bearing just slides right in. Those of you that are familiar with motorcycles and snowmobiles will recognize this as pretty much just state-of-the-art two-cycle mechanics. Okay, now we're going to assemble the piston. To do that, I'm going to put on a pair of glasses just so I can see a little bit better as to what's going on. Piston assembly consists of several things. Of course, it consists of the piston, consists of the wrist pin, 2 snap rings, and the piston rings. There's 2 of them. Earlier models of the 460 used a chrome ring on the top and a cast iron ring on the bottom. The later models used 2 cast iron rings. You'll notice a couple of things about the piston that are important to know. First, you've got this longer part of the skirt, wider. The next part is that it's got a narrow section on this side. This is important because it prompts the mechanic to know which side the piston goes on. And what I mean by that is that this narrower part of the skirt goes towards the intake side of the engine. The intake side of the engine is the side of the engine that has the impulse nipple on it. Another way to remember that is that it's the same side as the carburetor is going to be on. Now, when you get that far along and you've got that straight in your mind, just take the wrist pin. Sometimes it helps to run the rod up a little ways. Stick the wrist pin in the piston till it's just coming out. Then take the piston with the small side towards the intake side and put it on. Then run the piston right back down to bottom dead center. A tool that I didn't introduce to you right at the first was a pair of snap ring pliers. This is a tool that will make it possible for you to put these little snap rings inside the piston. They hold in the wrist pin while the engine is running, so the wrist pin won't come back out. Now, take the snap rings, stick the nose inside the holes in the snap ring, and put it inside the groove. Now, a word of caution right here is to take and visually inspect and push on those snap rings. Make sure they're well seated in that groove. Then I always push the wrist pin up right against the snap rings. Take my second snap ring and put it in. And once again, push up against it and make sure that it's well seated in that snap ring groove. Then you're done with your snap ring pliers. Now, it's important that if you receive an engine and you tear it down and you take the rings off the piston, that you put the rings back on in the same order. What I'm trying to say by that is that there's a top ring and a bottom ring. And as the engine runs, these rings seat. And so they develop their own characteristics for that particular position in the engine. Now, this particular engine was assembled originally with this as the bottom ring and this is the top ring. So I'm going to make sure that when I assemble it now, that it's put back in that order. You'll notice another thing. The piston rings have a little dot right on the very top of them. This is to let the mechanic know that this face of the ring is the upside of the piston ring. Okay. Now, another thing that you want to notice is that on this side of the ring, there's a little notch grooved in there, or ground out of there. This notch corresponds with a ring retainer pin that has already been assembled inside the piston. Now with that, I'll find the retainer pin, make sure that the dot is up, this being my bottom ring. I'll put it on and I'll slide the ring so that notch fits over the top of the piston ring retainer pin. The very same thing with the top ring. By the way, the ring retainer pins are 45 degrees off from each other, so once you find one, it's real easy to find the other one. Okay, now that the rings are on, it's time to use the ring compressor. This is going to be kind of tough to show you exactly the proper technique for this. This is a ring compressor that we've made here at the shop. We find that it works particularly well for us. How you use it is you grab the rings, pull them up against the ring retainer pins. You put some pressure on them like so. Put your index finger there, halfway between those ring retainer pins, place the edge of the compressor, slide it on. Hold it there, take the other half of the ring compressor, put it on, and then spin the nuts down, or bolts. I always check right here to see if there's a crack. You'll notice there's a crack right here. That means that the rings aren't quite seated properly yet. So, you take them, squeeze a little bit, Just work the rings into position. Okay, something else that you'll find real handy and helpful in your assembly procedures is to use some sort of lightweight oil. This is 556, something that we use here in the assembly room. We've also found that WD-40 works very well. What you do with this, spray the dome of the piston, the skirt, then take your cylinder. It's time to put the cylinder on now. When you do that, the very first thing you want to do is you want to check all of the ports. Make sure they're clear, if there isn't any dirt, carbon, oil containing any kind of metal parts. Make sure that it's uncontaminated. Once you have that inspection completed, I always take a look to make sure the studs are in, the gasket is on, the 4 holes are all tapped. The 2 holes on this side, of course, if the studs are on, then you know that they're tapped. And then I take a look at the bottom. Take a look inside of the transfer ports, look for any kind of dirt, contaminated oil. Just be very cautious and sensitive to any kind of a contaminant that may be inside of there. Then take the cylinder, take your oil, lubricate it very well. Take some, wipe off the oil off the top of the flange. Take your silicone and put it around the flange. Once again, just a little tiny bit. Wipe it on with your finger. Take the cylinder. Make sure the intake port, the one with the studs or the 2 holes that's oblong shaped, whatever you want, however you want to key off of that, face it towards you. Make sure that the impulse nipple is facing towards you. Make sure the narrow side of the piston is facing towards you. Get ready for some close work. Put the cylinder right on top of the ring compressor till you feel it seat. Then slide it right on down. Now this particular compressor, you have to be cautious of the fact that when you undo it, you can scrape the cylinder right, or you can scrape the silicone right off the bottom of the flange. So tilt it to one side and then the other. Let the cylinder come right down. Take these bolts. You'll notice the difference between the cylinder bolts and the head bolts. They're the same thread, but the head bolts are a little bit longer. Also notice that there's washers that need to be put on there, and then just assemble it. Now these bolts also have a torque rating of 30 pounds. And it's an important torque to be able to maintain. If these bolts are improperly torqued, lots of times the cylinder will sit on there a little bit crooked, and the piston will drag as it goes through its strokes. Once you've got the bolts tightened down to where they're on the washers, take your torque wrench, adjust it to 30 foot-pounds once again. Take your bear claw, put it on there. Hang on to it. We're going to do 4 repetitions in the Charlie Atlas Weedhopper course for your biceps. Torquing these bolts, 30 pounds each. Now when you're torquing these, the thing to remember is to work kitty corner. Go from one corner, torque this bolt, and then come to this side and torque that bolt. Torque this bolt, and then torque this bolt. That way, everything is brought down evenly. Okay, then it's time to assemble the head. You'll notice the head has 2 spark plug holes, normal squish band compression chamber, and a couple things that you'll want to take note of is to look inside of there to make sure that the threads are in good shape. Make sure there's not excessive carbon buildup, because this will cut down the power a little bit. Now, this is real easy to assemble. All you do is you take your silicone, put a little tiny bit right around the compression chamber, smooth it out with your finger. Take it so that the fins are going with the direction of, that the air will be flowing over the top of them. Then take your bolts. Once again, they're longer than the bolts that go inside of the crankcase. Have a washer on them. Put them in all 4 of the holes. Now that you have the 4 bolts in the head, take your 5/8 socket. We have it on an extension here in the shop. Put it on and just screw it on down. Finger tight. Then, after you've got them down finger tight, put your torque wrench on there again. This torque is 30 pounds. And just complete your Charlie Atlas course. After you've tightened down the last of those 4 head bolts, then you're ready to assemble the carburetor. The carburetor goes on the intake manifold, which, as you will note, if you've done everything properly, you'll note this relationship. The nipple and the carburetor is going to go right here. The carburetors that we're using right now are the Tillotson carburetor. The way that you assemble this is to take your silicone, put a little tiny bit right around the edges. Steer clear of this little mark right here. Some of the Tillotsons have a little hole right here. You'll not want to fill that up with any kind of silicone. Take the carburetor and put on the gasket. There's a little bit of gasket sealer underneath this gasket that was done during pre-assembly. Also, the studs were put in at pre-assembly. These studs are Loctited in. The Loctite that we use here at the factory is an RC620. It's a permanent Loctite. Those studs won't come out very easy at all with that type of Loctite in there. Take the carburetor. This particular number has the jets in the front, the nipple going towards the cockpit. Just slip it right on there. Now, you will note that the carburetor is bolted on with 2 1/4-28 nuts. Don't make a mistake and try to run 1/4-20 thread nuts down on the tops of these studs. If you do, you'll ruin the studs and you'll have to replace them. Another thing you'll note is there's a couple of washers here. These are cadmium 2-plated. This prevents any kind of rust or corrosion. And these washers are right on each stud. Okay. Then take your nuts and screw them on. This is going to be a little difficult once again for you to see. You have to lift the carburetor up for a little bit of clearance and put one on just a little ways. And around the other side, lift the carburetor up for some clearance. Put the nut on. These are 7/16 nuts, and so you just take your 7/16 wrench, tighten it down on each side. It's important that it's tight because any kind of air leaking through the gasket into the port or the manifold will make the engine run bad. Okay, now that we've assembled that, the engine is almost done. We're heading now into the part of the engine construction that is almost always the cause of problems, and that is the assembly of the points and the timing. An improperly timed engine can do everything from run hot to lose RPMs to, well, just almost everything that you can possibly imagine that will make the engine perform poorly. Whenever an engine is sent back, the very first thing that we'll always do is check the timing. And we would pass that little tip on to you as dealers, that the very first thing you do when you're out in the field with your customers, check their timing if they're having a problem. To do this, I'd like for you to just take a look here at this engine. This engine has the timing mechanism already on it. The 460C uses a 2-point system. This set of points are the points that are turned on when the engine, when the switch is in the start position. This set of points are the points that are on when the engine is in the running position. This is very important. It's absolutely critical that the customer understands that when he wires up his engine, that this set of points are wired to the starting set, and these set of points are wired to the running position on the switch. Now, I'd like the camera to come, I'd like y'all to come right here behind me and take a look at how we assemble the points, and then I want to show you how to time it. Well, welcome to the other side of the engine. Just to introduce to you a little bit about this. Once again, these are called the standoffs. They should be drilled and tapped with an 832 tap. On both of them, the holes for the standoffs and the holes for the running plates, for the running points, I should say. I always take note right about this time to make sure that the half-inch shaft on these later model Chotia 460C engines are also drilled and tapped with a 1/4-20. Later down the line, this will facilitate the use of the recoil starter, which is an item that I'm sure that some of you have been waiting for and are looking forward to putting on your airplanes. I'd also like to take a minute right now and introduce to you the components that make up the points system. So let's move the engine out of the way and introduce to you, first of all, these are the starting set of points. You can't tell if they're starting sets until you look on the back, and you'll notice that one of the 832 screws comes all the way through. Also, with the starting set are a couple 832 screws. They're about 1/2 inch long. You'll notice that they have a couple small star washers on them. Also, between the points plate and the standoffs are just a couple of number 8 washers. And then, of course, you have your condenser. And that's all that makes up the starting set of points. The running set of points have the very same components with a couple of differences. You'll notice the same set of points, but you'll notice on the back that the longer 832 screw has been sanded and ground off so that it's flush with the plate. You'll see the reason for that in just a few minutes. The only other difference between the starting points and the running points is that it has some smaller in length at number 832 screws. And then once again you'll notice that it has the star washers on there, and these are important. It needs to be assembled with these star washers so that it won't come loose while the engine is running. Okay, to assemble the points, you need to use your silicone again. Now, take your silicone, come over here to your standoffs, just use a little tiny bit and squirt some inside the hole. The reason we do this is it seals these holes from any kind of leak or any compression that might come back through these holes. And I do it on both sides. Then take your flat washers, just stick them right on the standoffs. Then take one of your long screws with the star washer on there, and you will see that it's very easily done. Just screw one on. All right. Then you do the same thing with the bottom screw, except take the screw and insert it through the condenser and put it in. It isn't very uncommon for the mechanic to forget to put that condenser on, so put a double check in your notes for that particular operation. Take your 5/16 wrench and work with your coil wire or your condenser wire and just put it on. One thing, especially in the earlier models, you have to be kind of cautious of is that this condenser wire doesn't come up and touch on the points plate. If it does, it will short out the whole system and the engine won't start. You may make a note of that for those of you that are going to be troubleshooting some of your customers' engines. Then come around to the run side of the engine. Stick on your flat washers. Take your points. And the little 832 screw, and just screw it in. And there you have it. That's the assembly of the dual point system. The next part of the program that we'd like to go into is, of course, the timing. And once again, you just can't talk enough about how many times people who complain of loss of RPM or low power are just experiencing this because their engine is out of time. Timing is really a simple procedure to somebody that has done it a couple, 2 or 3 times, and for somebody that has the proper tools. Now, in case you've forgotten, I'd like to take the time once again to introduce to you the tools that you need to properly time the Chotia 460C. They are these three tools. You will need to run down to Radio Shack and pick yourself up one of these 995 ohm meters. Also, something that a lot of people have purchased that works well are the timing lights. This is just a light that turns on and off. When they're on, it usually indicates that the points are closed. When it's off, it indicates that they're open. The next thing that you'll need is going to be a pair of feeder gauges. In particular, you're going to have a gauge on there that has 17 thousandths, 0.017. Thirdly, and most expensively, is the dial indicator. As I mentioned beforehand, we like this particular brand because of the little feature down here with the threads on it. This enables us to just screw the dial indicator right into the hole, and thus we maintain our perpendicularity, our parallelness, and we can come within 1,000th, even 5/10ths, of having an engine properly timed. And so we highly recommend this style, not necessarily this brand, but this style of dial indicator. Okay, well, let's get on with it. You take the dial indicator, and like I've been saying, you just screw it right into one of the spark plug holes. Screw it right down. It doesn't have to go down all the way if you're in a hurry. Just screw it on down. You'll notice that these dial indicators have a little face that spins around. The hand does not have to be on 0. Okay, but I'll put it there. I'll spin it away. It doesn't matter. You'll see what I mean as we continue through the demonstration. Then, with that done, take your feeder gauges, pull out your 17 thousandths feeder gauge, and adjust your points. To do this, we're going to have the camera come in real close and take a look at these points. I want you in particular to notice this screw, and I want you to look at the relationship of the point gap and where that little block is, that little piece of plastic is on the shaft. You will observe that the points are closed right now. Now, this is incorrect. The points in this position should be being pushed from the shaft, open in this position, 17 thousandths. Now, to do this, all I've got to do is loosen this screw right here. Don't mess around with the top and the bottom screw just yet. It's this screw right here. Just loosen it up a little tiny bit. Push those points in till they contact the surface. You'll note right now that they're opened. Take your feeder gauge and insert it. Now, I've happened to be real lucky right here. I've got exactly 17 thousandths right now. Let's hope that we can do that on the other side. Take your screwdriver, tighten down the points, and be extra observant right now, because many times as you tighten down the points, the torquing motion can actually close those points a little tiny bit. So take your feeder gauge again after they're tight and double check it. Now, you have a tolerance on this. You can gap them anywhere between 15 to 20 thousandths. Anything under 15 thousandths is too close and should be regapped. Anything over 20 thousandths messes up the timing a little bit, and it should be regapped again. A note that you should be aware of is that the shaft, as it rotates while the engine is running, will wear down that plastic for about the first 20 hours. I tell your customers they should be informed that that in their pre-flight they should develop the habit to check that point gap. Okay, now we'll just go to the other side, and let me see if I can turn this so that we can see it a little bit better. Once again, if you will observe, the points are closed. The plastic on the block on the points is running almost on the shaft, yet the points are still closed. Our object is to get those open, 17 thousandths. To do that, we're going to loosen that screw up right there, 17 thousandths, or just loosen that. Then we're going to push those points in. Oops. After you've done a few of these, you'll get to where you can see what 17 thousandths looks like. We've got a little bit less than 17 thousandths right now. So I'm going to take my hammer to delicately tap that. That was a little bit too much. There we have it, right there. Take your screwdriver and tighten it up again. Okay, that's how you set your points gap. Now let's turn the engine upright again and bring into use this little feller. This ohm meter has a battery in it, and it's hitched up to a circuit so that when you plug this one, the black lead, into your AC volts and your K omega over here on this side and touch, you'll notice that the needle jumps. Okay? Now this is used in timing in this manner. Take the ohm meter. I'll put it right here so that you guys can see it. And stick the ground, black one, in a hole somewhere, like that. Take the positive, touch it right there. Now, what we're going to do is to rotate the shaft until I see the hand on the dial indicator come up to top dead center. And if you'll watch, I'll just show you how to find that. Okay, here I'm coming up to top dead center. Here it comes. Right there. It stopped moving. I'm still rotating the shaft. See it fall back down? It's coming back down. Okay, so I want top dead center. There it is. Right there. If you want to, and I recommend it, go ahead and set it to 0. Check that top dead center mark again. Alrighty. Now come back down to our ohm meter. You will note that there's a current flowing right now. That would indicate to me, since I've got my positive lead touched right here, that there's a current flowing all the way through this engine, being induced by the ohm meter. I need to have those points break within plus or minus 5 thousandths, 5 of these little hash marks to either side of that dial indicator. 5 of those little marks to either side of 0. Let's see if we've got it. I don't think we do. I'm turning it. We've got it. Okay, let me tell you how I found that. We really lucked out. It's highly unusual. We're at top dead center. I begin to rotate the crankshaft in the direction of rotation as the engine is running, which would be Counterclockwise, as you stand in front of the propeller, I'm watching for 5 thousandths movement here. I'm also watching to see if that needle falls, which will indicate to me that the points have been broken. Now watch. If you can watch just both of those at the same time, you'll see that the needle hardly moves. Well, it moved about 90 thousandths, well, not even that, about 9/10 thousandths of an inch before the needle fell. So I have, on that particular set of points, I'm right on the money. Now, here's where the use of the dial indicator comes in real handy. We need to have this engine, when it's running, fire 200 thousandths of an inch before it reaches top dead center. The way to get this is to back it, or to turn the prop flange opposite the direction of rotation, which would be clockwise as you're facing the engine. Let me show you how to do that. One revolution on this indicator is 100 thousandths, so we'll go around twice for 200. There's one. I'll come up to my zero mark again, and there's 200 thousandths of an inch. Okay, now that we've got that 200 thousandths of an inch before top dead center dialed in on our dial indicator, we're going to come over here to the run set of points. And I'm going to touch my positive. Oh, wait a minute. I'll put the dial indicator right here so you fellas can see it. I'm going to touch that positive lead, and you'll see the current flowing right now through the engine. I'm going to turn the engine, I'm going to turn the engine either way, clockwise or counterclockwise, to try to find out if I'm within plus or minus 5 thousandths of that 200 thousandths. I don't think that we are. Oops, that was 7 thousandths. The needle has not fallen. I'm going to come over here on this side. The needle still has not fallen. Okay, here's how to adjust that. You take dial indicator, I'll move it over here to the waves. Take your screwdriver. By the way, the secondary or the running set of points, as they're named, are the hardest ones to time. Don't be frustrated if at the very first time you have to spend a few minutes trying to time these secondary points. It's very common for a mechanic to, a beginning mechanic on the Chotia 460 to spend a good hour the first time trying to time one of these things. Okay, a trick that I've learned I might pass on to you is if you put your needle right back on 200 thousandths, come down here to where you can see the block and you can see the edge of the cam. I hope you can see that. The block on the points and the edge of the cam. Take a look at that. You see how close you are to breaking? Now we're really close. We're within about within 5 thousandths, I'd say, of having that thing break. I'll check it again. And you will notice that the points have already broken. When I tightened up that screw right there, it must have moved the plate just enough. Let's check it and see if we're within tolerance. We are not. We're still 6 thousandths out of tolerance. But since this is John Chotia's engine, we're going to have this one right on the money. Okay, I'd like to take this ohmmeter and move it up by the dial indicator so that you can see the correlation between the two a little better, and then show you a couple of tricks to getting this secondary or running set of points timed within tolerance. We'll take the positive lead right here, and we'll notice that the dial indicator is indicating about 2 1/4 thousandths off of our advanced mark, I'll turn the prop flange just a little ways. I'm turning it in the direction of rotation, by the way. At 4 thousandths within tolerance, the points are breaking. So I know that if I could just move the points a little more this way, a little more away from the shaft, that I'll be able to get it even closer. Let's see if we can do that. I'll take my hammer, I'll take the screwdriver. Now I should point out that I've tightened down these screws so they're tight, and I'm going to just tap that. Doesn't take too much sometimes. Let's check it again. You'll see the ohm meter has jumped. My points are touching. There it is. Look at that. You will notice that I'm putting some pressure on the prop flange. I'm trying to rotate it, but just a little tiny bit. But the indicator, it is enough that even the indicator is moving, which would indicate that piston's not even hardly going up and down, but the points are breaking. So there we have it. It's right on the money. That engine is firing 200 thousandths before top dead center right now. Okay. In synopsis of timing, the key points to remember are that your starting set of points are going to fire at top dead center. Your running set of points are going to fire 200 thousandths of an inch before top dead center. These measurements are all indicated by the use of the dial indicator, ohm meter, your feeder gauges. And when you have those basics down, you will develop your own personal tricks, ability for timing the Chotia 460C. We would like to remind you, as it's written in the engine manual, that the Tillotson carburetor's jetting is 2 1/4 turns out on the high-speed jet, 3/4 turn out on the low-speed jet. Some of the Tillotstons have fixed jet in them. If this is the case, the jets are obtainable through motorcycle or snowmobile shops. You just unscrewed the cap screw. You'll find the fixed jet inside of there.